with whatever we do. Jioni safu no la with whatever we do. Hale yide munyu skula nyepamne ne kudlukula nyepangi ragala gena nyepamne ne kudlukula ibuloke nongoto ni beti sola ibuloke dato ni betoto
Mingi Congo
Lamin
na
Lamin te jibe norin te nyame Lamin
kabana
wulo ko no nyinta mo Lamin
pabilenki
muna ngata afongole
haina
ngata Koto le Fabrama
Mingi baba nyola
Koto le Fabrama
Namu jumara kan kuma diten
Fabrama
jumara
ndele bare muso
lunda mana
kata
jamani bere
alindo ko
jamani
bari koto man kontande
bari jamani fana na mudu wa kontan
koto minaka ngala min de fon filitala lamin jibe nori nyaala
lamin ila siran sama ne benki yala so tol sayni no ko mo lakko momo
koto
nam
itedinte yalo ne lamin hakkilo diata bake karambugot anu santeng ministry ko di ngole si suko na amake ko do holi de
si bitun
bagona de
ala ni ko kede namo balo
ala ni na ko na karta bulo be damna ala ni je
koto
nam
koto mon kontan fere
jamani mu ne keda
ifika lamin ki wulo ko no nyinta mon koto fete malo lamin nyanta sila la be la moy kala karango
jamani karamol be soron ne ko fasita wulo ko nako
karambugol ma soron ni ko karambugol soron da amake ko mo holi de lem koto dindi ngo nyanta sila la ala karango la moy yamen kamen fue man kontaan andamande
alla nyin kombo courant adanda la kombo len do la jan karamol soron do kamen courant ma rado la kombo e don do fana na karamol soron je karamol soron lamin ada lo nyino la man tara fe na sokon ala mu nekela
am lamin ite fo de malon ko la sinol be ke kar radio to
nga fine
e ko yana di mod lamin ya mu na fonye
bi kabin mina kan tambita nteri maning Fatu tambide la sukala ala dinngol bebe siri be la moy ka
faru danso am fana tambida jele ni subala la ngaje dinngol be jet talanta nen kili waro e be seri jele
sa lamin fanante ku kili wo ke no la ba bad lamin bi taka wulo ko no nyin taymo alami
amandara fenela
ite dine ko ni man si yakaru la suno la moy radio to e balon na
muneka ke afonde ma nyaara ni alon
telentel jikot
afonde ma munebe ke
ite balontel be jikritel ni man karambe ku kele yaaje nata karana mbasa mala ya e tarije
par ñarande kombo courant ho findira kombo ide na raje den sonka bay ko lamin manya tala wulo ko karam mo be so dafa nyembe
ko to wole nati bawo ngalle ni lamin kuntala kombo courant o ka fa me kombo courant asototal wala kinay ko e sisu ko no bari ni ko e sisu ko no be karangol di ke la radio lin telel to hani tele masoto to nyaay man tele soto da bongo bar radio be bulen ko to batiri sanga ay si ay alamo
sa do kala nyaadi
ko ta o bulaji
ado kala nyaadi
kamun ke nyaadi
radio abe wala mo la be mona falaje
ibe la karandirol kala jele
ti talle be radio ko men ka karandirol
ila subjector baby jele baby jele
wala nanga chocho moy fa dan so wala ngombe tambi kana ngadi ningol de be ikadum bungo de ko kada marmo
ma asototal de
la min mala be kara wala de
bari
laftalal ideal on ko inde every year second wala fourth
mona ni ko di ha ko de ko folle sinila ba ndele sinilo ne ba
mba say mba foke en koto wole fango yen wulindi yalo famo keta bat yin fana bulata ko ko me yen nati jambi lamin nyanta karana ntel beji ko be nyineka ya bulay kara wulo kono ta kilar ya bambalo yo be bulaje koto dindi ngoy si ayala le sino la moy radio
wara ka munda kara mo man soro lamin nyanta kara si so na radio
la sila le ayala le sino
dal ko korno ko smalo
kilar ya
mo be ngala ko momo say mi do ni ko no kera
mengi bruzo
ndelo ko la da ba rosa no radio ba no bari woro radio ni abe jele ba ngam radio man dembe guljan dala nyara nyara woro ko fendi mo la lamin tayra ba rosa
bara te ku folo ajibe nori nya labi tamete ku
teku
bari ko do famo ke
image nani nyambol si zol le keje kisigi man si zol no le kafun ka nyoma bari nyambu kino ni manya na kafinde ni nambe ko zol laga
ngalle limbeta de be nyambo do dilanna
nyara ni ko ridin fennat nyara nata
bari famo ke da
nata bungono tabi bungono nyara ngando ko fele ko ke baru nganda ni pelo andija bismillah bisu diara
pendulala ye fongo tanka sina dolu tanka koro ta koro ta
Good day, viewers out there. I welcome you again to another maths lesson for senior secondary school. I am Mr. SEN.SEC. The topic today is on the trigonometric, that is sine and cosine rule, or sometimes stated as the law of sine and cosine. Sine and cosine is a subtopic under the topic trigonometry, which was discussed previously, and under the main theme, that is geometric, that is the branch of mathematics. So we'll be dealing with sine and cosine problems. We're not going to prove it, but how to use sine and cosine problem to solve triangle problems. That will be our target today. The prerequisites. We have topics that, if covered, will help a lot in understanding this particular topic that we are covering today, that is sine and cosine rule. These topics are ratio and proportion. Is very important because we'll be dealing with ratios of sines and ratios of sides and that of the angles. Types of triangles. You need to know whether a triangle is a right angle, it's an obtuse angle triangle, and other type of triangles as well. Pythagoras theorem, this is covered with that of a right angle triangle. You need to know because I'll be emphasizing that the triangle that we're dealing with, they are not right angle triangles. So we can't apply Pythagoras theorem, but it's been covered already in the previous lesson. And we have trigonometric ratios, which is also very important prerequisite for this particular topic. Congruent and similar triangles is the most important part of it. You need to know what are congruent triangles. If you know congruent triangles very well, you don't have any problem in this topic for sure. Laws of sines or sine rules. So far, we have been working with right angle triangles. All the problems that we solved previously, the previous lesson on the trigonometrics, they are all on right angle triangles. They are all on right angle triangles. Triangles that have one of its angles exactly equal to 90 degrees. But what about other triangles? How do you solve the sides and the angles of other triangles that are not right angle triangles? So to do that, this law of sine and cosine will help us a lot to tackle triangles that are not right angle triangles. If you know the measurements, or the measures of enough sides and angles of triangle, you can solve the triangle. That means if you know enough sides of a triangle or the angles of triangle, we can solve the ones that you don't know. Or we can find the other sides as well. The law of sines can be used when two angles and the length of any sides are known. We can apply the law of sine or the sine rules on any triangle that we know of two sides and the length of any sides that is given. So in other words, I'll explain further what this AAS and ASA means. It means angle, angle, sides, or that of angle, side, angle. That means we know two angles and a side. Or when the length of two sides and an angle opposite one of these sides are known. That is, if you know two sides of a triangle, triangle always have three sides. If two sides are given, the values of two sides are given, and one angle, we can also apply the law of sine to find the other missing sides and angles. Move on. The law of sine or the sine rule relate the sines of the angles of a triangle to the length of the opposite sides. The law of sine relate the sines of the angles and the length of the opposite sides. This is a triangle. The triangle is we have a triangle here. In triangle ABC given below, this is a triangle ABC. You can see the three sides of the triangle are A, angle B, and that of angle C. We'll use this, looking at this given triangle here, we can deduce the law of sine there. The law of sine relates the sines of the angle to the opposite sides. If you look at this triangle here, we have angle A. This angle is directly opposite to the side A there. That is the length BC. And then we have another angle, angle C, is opposite the sides C there, small c. So capital letters are used to represent the angles and small letters to represent the sides. And that of the last one there, that is angle B there, is opposite the side here. Side of line segment AC is called B there. So these three sides, we relate it to the three angles using the law of sine, of proportion. The law of sine states what? The sine of angle A is given, over A, the side A, is equal to the sine of angle B over side B, opposite, the opposite side, and the sine of angle C is opposite over that of angle C. That means the sine rule or the law of sine says what? If you take the sine of angle A over the length A, that is equal to the sine of angle B over the length B, which is also equal to, proportionally equal to, the sine of angle C over C. This is what we called, this is what we refer to as the sine rule or the law of sine. But it can also be flipped in another way around. That is, we can also have it in another form that also works. Instead of the sine, because these are proportional values. If sine A over A is equal to sine B over B, which is also equal to sine C over C, then we can also write this in another form that is the same as A over sine A, angle A, which is also equal to B over sine B, which is also equal to C over sine C. You can use either of them. If you use this one to find the value of a missing side, or that of the one on top there, we'll still get the same thing at the end because we're solving for the same. These are proportional values that are equal. The ratios are all equal down there. So it said that note that any one of the angles can be obtuse. That means this triangle given, one side must be obtuse there, which is fixed because we're not dealing with right angle triangle. To solve right angle triangle problems, Pythagoras theorem and trigonometric ratios will do the job for us. But what about if you have other triangles that are not right angle triangle? That's where we apply the law of sine and that of cosine to find the missing side or that of the missing angle. So one of the angles there must be obtuse. So you can see there. And so far, we only find trig values of acute angles. So it's very important that you know that we are finding the trig values of acute angles there and that of the sides as well. Let's state the law. The law of sine states what? We use this law, use the law of sine when we have the following situation. If you are given a triangle, let's say that's our given triangle. Could be A, B, C, if you want. We use the law of sine when we know these three things hold of the triangle that is given. That is, we know the sides, the angle, sides, angle. We call it ASA. That is, if you know the side of one angle, that is angle C there, and you know the side, that is the length from B to C, that is the small a, and you know another side, that is B there. We can use this and apply the law of sine to find the missing sides and angle. That's one angle missing, A, and that of the two sides, that is side C and that of side B. We can apply the law of sine to find any missing side or angle in this triangle because this holds. That is, we know of two angles and an included side. We know of two angles and an included side as well. So we can apply the law of sine. Again, we can apply the law when we know angle, side. That means if two angles are given on a side, angle, sides mean if two angles and a side opposite to one of them. That means if you are given two angles, let's say angle A is given, the value there is 30 degrees. Angle B is also given, the value, for example, is 60 or 70 degrees. And one side is also given. The side that is given must be opposite to this angle A or this angle B there. One of them is given, that is two sides and a side opposite one of the angle. We can apply the law of sine to find the missing sides. That is, if we know two angles, we know one opposite sides of one of the angle that is given, we can apply the law of sine to find the other missing sides that we don't know. Like that. The third scenario or case in which sine rule can be applied is when you know two sides and an angle. The two sides and the angle opposite one of them. That is, let me draw another one for you to represent that. If you are given a triangle, P, Q, and R. Two sides. Let's say this side is given 4 centimeters. PQ is also given 5 centimeters. Two sides and the angle opposite to one of them. We are given two sides. The side opposite to that angle side is angle R. Let's say this is given as 40 degrees. So we know two sides of the triangle and we know one angle that is opposite to one of the sides. With this kind of triangle, we can apply sine rule to find the missing side or that of the missing angles. If you ask to find any of this one of this missing side or the missing angles, we can apply sine rule to find the missing side or the missing angle. So these are the three scenarios. We call them, the short name, short abbreviation given to them is angle side angle is angle side angle. Angle side angle, we can apply the law of sine to find the missing side, or angle sides. That is, if you know the two angles and one side, we can also apply sine rule. And if you know two sides and one angle that is opposite to one of the sides, also we can apply the sine rule. So these are the three scenarios or three cases of triangles, problems of triangle that we can apply the law of sine to find the other missing side or missing angles. So let's deal with examples for you to see. This is just for clarity and convenience. Note that AC, line segment CB. Why is CB in this triangle? CB is this length. It's a line segment. The line segment CB is a side. It's opposite to angle A. Angle A is here. The line segment CB is opposite to angle A and has length A. It has the length A. The length there is A. It can be 2, it can be 5 centimeters, any value can be given there. So, want you to understand sine rule very well, how it is applied. You have to understand what is the side and what is the angle opposite to it. This is the angle and this is the side opposite to angle A and it's labeled as small a there. AB is this side, this other side. From A to B, we have a length AB. And it is opposite to angle C. Angle C is opposite AB, line segment AB is opposite to angle C, and it has a length C. Length is given. So the distance or the length from A to B is C. It can be 5 centimeters, it can be 10 centimeters. But you should know that this side is the side opposite to this angle. AC is another side given. A to C, that is this side of the triangle ABC. It is opposite angle B there. Opposite angle B, you can see. Directly opposite. And it has a length B. The length is B. It can be given 5 centimeters, 10 centimeters. So you should know the difference between these sides and angle, because sine rule says that if you have sine of A over small a, that is equal to the sine B, all that over B, and the list goes on side C, all that over C, on the three sides. Yeah, we have to solve this triangle. If you look at this triangle, it's a angle, side, angle, triangle that is given there. We know two angles and a side, included side between them. So we have to solve for the one angle that is not given and the two missing sides. To do this, we'll start with the angle because it's helpful. To apply the law of sine, you need at least to know one side and its angle. One side and opposite angles. So if you look at this, we know this angle, this is 40, but the opposite side is not given. Angle B is given, but the opposite side, the value there, the length, we don't know. So, but the length of one side is given, that is C. So we have to find the angle C so that we get the side and angle of angle C there. And to do that, we get angle C as 80. How did we get the 80? We know the sum of the angles in a triangle is 180 degrees. So all what you do is, you take the sum is 180, so triangle sum. So angle C therefore, if you add all the angles together, angle A plus angle B plus angle C is equal to 180 degrees. If two sides are already given, that is 40 and that of 60, together is 100 degrees when we add them together. So to find angle C therefore will be equal to 180 degrees minus the two sides that are given, that is 40 plus 60. If you add it to, you get 100. 100 from 180, that will give us, therefore angle C will be equal to 80 degrees. So we find this 80 degrees by adding these two angles together and subtracting from 180. That will give us this angle that we solve for, angle C there. Angle C there is 80 degrees, that is this point there. If you know angle C, then we can use the ratio of that angle C to the sides as one of the ratio that we are going to use to find the other missing side. That means angle C, both the sides and that of the angle are given. How do we go about this? We take angle C, that is sine C all that over C is equal to sine B all that over B. That's what we have there. Sine C all that over C is equal to sine B all that over B. Our sine C, that's what we solve for, angle C. Angle C is 80 degrees. The side opposite angle C is 12. That is AB, the length AB, divided by 12. That is equal to sine B. Sine B is 60 there. The side opposite angle sine C there, sine B is small b, which we don't have value for it for now, so we are going to solve for that. If you look at this proportion here, this two ratios there, almost all the three sides are given. There's only one side that is not given, that is the small b. We know sine C. Sine C is what we solve for, that is 80 degrees. C, the value that is the length, C there is also given, is 12. Sine B is given, that is 60. So the only thing missing there is this B. So by equating these two and solving this problem, we're able to find the B that we are looking for. So what do? You cross multiply from here. B times sine 80 will be B sine 80. That is equal to 12 times sine 60, so 12 sine 60. But we are solving for B. To solve for B, we divide both sides by sine 80, so B therefore automatically is equal to 12 sine 60 all that over sine 80. So 12 sine 60 all that over sine 80 will give us 10.553. And then to find that of another missing side, that is A there, what do we do? What do you have to do? You have to look for another proportion. But since we know angle C and the side C, we are going to maintain that. That is sine C all that over C equals to, but to find the opposite side of A, we'll use sine A all that over small a. But we don't know the value of small a, so we take the two ratios, proportion values there. So we substitute all our values in. From there, we cross multiply. A times sine 80 will be A sine 80. 12 times sine 40 will be 12 sine 40. Then we divide both sides here by sine 80. So A automatically will give us 12 sine 40 all that over sine 80, which is approximately 7.832. We move on to another example. But here, this example, we are dealing with another type of triangle that we can apply the sine rule in. This type of triangle is what we called AAS, that is angle side triangle problem. The example is given, given angle A equals to 25 degrees, angle B 97 degrees, and the length of B, that is side B, is 8 degrees, solve triangle ABC. To solve the triangle, I've drawn the triangle there for you already. ABC, triangle ABC. Angle A is 25 degrees. So I've labeled angle A there, 25 degrees, given the value there. The measure of angle B is 97 degrees, so 97 degrees is there already, and that of B there is given, is 8. To solve this problem, you have to analyze it. What are the sides that we don't know? Which side are we to solve for? We don't know this angle, angle C there. It's not given, so we have to find angle C. A, small a, we don't know the side, we have to find it. And small c also, we don't know that. So these are the sides, the two sides, and one angle that is not given. Those are the 3 points that we'll solve for, 3 areas. So by triangle sum, the sum of the angles of a triangle ABC is equal to 180 degrees. So if we are given two sides, add the two sides together, subtract it from 180. 97 plus 27, that will give us 122. Subtract it from 180. 180 minus 123 automatically give us 58 degrees. And that is angle C automatically equals to 58 degrees. That is this angle, because if you add all the 3 angles together, it should sum up to 180 degrees. So if you are given 2, to find the other missing side, add the 2, subtract it from 180, it will give us the missing side. So we know angle C. Now what is left to solve for is the length BC, which is our A, length A, and the length AB, which is our C. To solve for the length A there, of the triangle, we are going to look at the 2 ratios there that will help us to find. By looking at this triangle, angle B and the side B, we already know it in the proportion. So sine B all that over small b is equal to sine A all that over small a. Sine B is sine 97. That is sine 97. So we have sine 97, B, the B value there is 97. The value for B, small b, is the side opposite angle B there is 8. So it's divided by 8, that's equal to sine A. Sine A is sine 25 degrees. So we can see sine 25 degrees, we input in sine 25 degrees, divided by the value of A, the small a that we are solving for. From here, we cross multiply. A times sine 97 will be A sine 97. Is equal to 8 times sine 25, so it will be 8 sine 25. We divide both sides by sine 97 to isolate to find the value, because we are solving for A. To find the value of A, we divide both sides by sine 97. So A will give us 8 times sine 25 all that over sine 97, which is approximately equal to 3.406. Now to solve for C, that is the side C there, the side opposite the angle C, we already solved for angle C, and angle C is 58 degrees. So if we know this angle, we don't know this side, but for that of B, we know both the angle and the sides. So we can use sine B all that over small b, that is equal to sine C all that over small c. You can see here, this sine 97 means sine B all that over small b is equal to sine C all that over small c. Sine B, the value is sine 97, divided by the side B is 8, which is equal to sine 58 is our angle C, because we already solved for that, all that over the small c there. If we cross multiply this, there's only one part of this proportion here, the two ratio that is not solved, that is C. So we'll be solving for C. To solve for C, we make C the subject, sort of. To do that, we first cross multiply. C times 97, sine 97 will be C sine 97. This is equal to 8 times sine 58 will be 8 sine 58. If we divide both sides by sine 97, sine 97, it will cancel out. So therefore, we'll be left with C equals to 8 sine 58 all that over sine 97, which will give us an approximate value of 6.835. So this is the way we solve for the AAS and AAS, that is angle, side, and that of angle, side, angle. Move on to the next slide. Now we have to solve for. If we are given the third scenario, that is two sides and one opposite angle, that is side angle. What are the two sides? The triangle there. We are given one side, that is the length of A is 12.5 centimeter. We are given another side, length of C is 17.7 centimeter. And we are given one side. And this side is related to one of these two angles here, and that is angle C. Angle C is also given is 116 degrees. So you can see we have a side, we have another side, and we have an angle down there. So this is called side-side angle problem. We can apply sine rule on this to solve triangle ABC. What do we mean by to solve triangle ABC? To solve this triangle, we'll find the missing angles and that of the missing side. That's what it means. The missing side here is only one side, that is side B. We don't know the value of B there. We need to find the small b, side opposite the angle B. And angle B also is not given, so we have to find angle B and that of angle A. So we have two angles to solve for and one side. To start with, since we know angle C and side C, we'll use that one as our proportion there. Everything there is known, so we'll take applying sine rule, that is sine C all that over small c is equal to, we know the side of angle A. So we can relate it to angle A, that is sine A all that over A. We know sine C is sine 116 is given. So this means that we have sine 116 degrees divided by the C value is also given is 17.7 centimeters. So it will be 17.7 is equal to Sine A, we don't know this, the angle A there, so we don't know it. So we'll leave it as sine A. All that over, this side A is given, and that is 12.5. If I cross multiply this, I'll have 12.5 times sine 116 degrees is equal to 17.5 times sine A. What will this give me? 12.5 times sine 116 degrees is equal to 17.5 sine A. We are solving for A, the value of A, sine A there. To do that, we'll divide both sides here by 17.7. 17.7. This will go. So we're left with sine A is equal to 12.5 times the value of sine C, all that over 17.7. So we can use the calculator there and find the value if you want to. Looking for sine of sine 116, so 116. Sine will give us an approximate value of 0.899. That is for sine 116. So if you substitute that one in here, 899, so it will be 12.5 times 0.899, all that over 17.5. So we clear 12.5 times 0.899, approximate value, that will give us this value, divided by 17.7. This will give us the value 0.66349 to 4 decimal place. But this is sine A is equal to, it's not the answer. Therefore, sine A is equal to 0.6349. To find the value of A, we'll take the sine inverse of the value that is of the 0.6349 there. So automatically, therefore, A is equal to sine inverse of 0.6349. That will give us the value for the angle. I'm going to take the sine inverse of 0.6349 there. So sine inverse of this, give me this value. So I'll put in there as an answer. Therefore, A is equal to 39.41 degrees, which is approximately, another approximate value. This is our approximate value. A is approximately equal to this, which I can round it up to, if I want, which is approximately 39 degrees. To the nearest degree there, 39 degrees. That's the value for A. And that is this angle here, angle A. We solve for angle A, so that is clear. But if we know the value of angle A and that of angle C, by using the sum of the triangle rule, it's very easy to find that of angle C, because we know two angles. And the sum of the angles is always equal to 180 degrees. So we can find angle B which is not going to be difficult. To solve for angle B, all what I do is triangle sum, I know is equal to 180 degrees. So we are given three angles, angle A plus angle B plus angle C is equal to 180 degrees. That's a triangle sum. But we know the value of A now, and we know the value of B, which I can add, the value of C, which I can add the two to find the angle of B there. So this will give me what? The value of angle A is 39. We're going to use the approximate value, 39.41. 39.41 degrees plus that of angle B plus 116 degrees is equal to 180 degrees. Some of the angles in the triangle. If we add the two together, then we'll get the value of B. Therefore, angle B will be equal to 180 degrees minus the sum of these two angles, that is 39.41 plus 116 degrees. If I add the two together, this will give me what? That's 40, 55 point, will give us 180 minus 155.41, which I will subtract 180 minus 155.41, 24.959 degrees. That is the value of angle B, which I can approximate it easily to 25 degrees. So we are able to solve for this given triangle, angle B, angle A, and that of angle B. The only side that is missing that we do not know the value of, that is side B there. So we know the value of both A and C now. The only thing that we have to solve for now is the small b, that is the side opposite angle B. To solve for angle B, we can apply the law of sine. The sine law states what? Sine C all that over C is equal to B. We're solving for B. Sine C all that over C is equal to sine B all that over B. All that over small b. Sine C, the value for sine C, we know C. C is 116, so this will be sine 116 degrees. And the value for our C there, the length C, it's given here, 17.7 centimeters. So I'll substitute 17.7 is equal to sine B. We've already solved for that, so sine B will be sine 24.59. All that over the value that we have to find here, that is the small b. Looking at this, to find b there, first we have to cross multiply. B sine 116 degrees is equal to 17.7 sine 24.59. Since we are solving for b, we could divide both sides by sine 116 degrees, sine 116 degrees. Then the 116 will disappear, will go on that side. So therefore b will be equals to 17.7 times sine 24.59, all that over the value of sine 116. take our values and find sine 24.59 will be 24.59 sine. That gives us 0.41661 there. We clear that one out. And we have sine 116. 116 sine will give us 0.8988. If we are to solve this, 17.7 times 0.4161 give us this, divided by 0.8988, that will give us this value, which is equal to 8.1942. So we'll approximate it, the value, extend the page. So we can say, therefore, our B value is equal to 8.19 centimeter. 8.19 centimeter. So we're able to solve for the value of B and that of the angle A and angle B as well. So this will solve all the problems that we have on this particular triangle. We move on. We are given a particular question. Find B as the length of this side B, given that in a particular triangle, angle A is 40 degrees, side C is 7, and that of angle B is 75 degrees. So this, you have to draw the triangle and label the sides and complete the work there. So let's say we have, let's say that's our triangle. Looking at this particular triangle there, we have the sides are A, B, C, obviously, because two angles there are A and B. So let this be my angle A, because it's less than 90 degrees, and angle B down there, and then this be angle C. That's the triangle. We are given two sides and one angle. These sides are given, this 40 degrees is given, 75 is also given. So we have to solve for angle C, which we don't know, and the length of C, that is the side opposite C, is also given, that is 7. So the areas, the sides that we don't know of, that we are to find is B, a small b. Small b is the side opposite angle B, which is this point there. So we have to find the value of B. To solve for B, at least to apply the law of sine or the sine rule, we must have one side and an angle, included side and angle. And here, by looking at this example, no side and angle is given. So to solve this, first we have to start with the missing angle here. If we know angle C, then automatically we know the side of C. So these two sides, we'll use it as one of our values there, ratios there. Then we relate it to the B value, because B, the angle is given. Angle B is given with that of B, side B, to find the missing side B. So let's continue. We have to find C there. To find C, the sum of the angles in a triangle, that is angle A plus angle B plus angle C, is equal to 180 degrees. Why? Well, this triangle sum is 180 degrees. We know two of the angles. Angle B is 75 degrees and angle A is 40 degrees. So we substitute for A, angle A is 40. So 40 degrees plus angle B is 75 degrees plus angle C degrees is equal to 180 degrees. which we can easily solve. Therefore, an angle C is equal to 180 minus the sum here. The sum of 70 and 75 and 40. The sum there will give us 115. So this will give us 180 minus 115 degrees. That will give us 65 degrees. So therefore, angle C will be 65 degrees. So the value for angle C is 65 degrees. So if we know angle C now, we can use angle C to decide opposite C as one of our ratio, equate it to B sine B over B. So we'll apply the sine rule from there. To apply the sine rule states that sine C, all that over small c, is equal to sine B, all that over small b. Sine C is sine 65 degrees, so that will be sine 65 degrees, all that over. The length of C is given, which is equal to 7. This is equal to sine B, which is sine 75 degrees, all that over the B that we have to solve for, B. So it is B value that we are looking for. So all what we have to do here is to cross multiply and find the value of B. If I cross multiply this, B will go with sine 65, so it will be B sine 65 degrees is equal to 7 sine 75 degrees. If I divide both times here by sine 65 degrees, sine 65 degrees, then I'll get my B. Therefore, B will be equals to 7 times sine 75, all that over sine 65. The value of sine 75 and sine 65, you have to take the calculator over there. 75 sine is 0.9659 there. That will give us 0.9659. All that over, we clear. Sine 65 sine 0.9063. If you multiply this together, that will give us what? It will be 7 times 0.9659, all that over 0.9063. So 7 times 96559, that will give us 6.7613. Divide the answer by 0.9063. This will give me 7.46 centimeter. So therefore, the value of B will be equal to 7.46 centimeter. So we have to solve for B. The value for B is 7.46 centimeter. This is the way we solve for the missing side and the missing angle that is given. We have another example for you there, that is B. B, find the value of B when A is given, angle B is given, and that of side A. This also you have to draw a triangle for it. Let's say that's the triangle that we are going to represent with. Then you label the sides A, B, C. And you fill in the information given. That is, our A is 35 degrees. Our B is 85 degrees down there. And C value is not given. A there is given. A is opposite angle A, which is 7 centimeter. 7, only 7. So we have to find B. To find B, the value that we are looking for is this value. This one is very easy because we know the side and angle of B, and then we know the angle of the side and angle of A, and we know the angle of B. All what we have to find is that of the B value there. So you would take the proportion there, like sine A, all that over A is equal to sine B, all that over small b. We know the sine of A. Sine A is sine 35 degrees, which is over small a. The small a is 7. The length is equal to sine B is sine 85 degrees, all that over small b. So we are solving for B there, the B value. Substitute your values in. If you substitute all your values in and you make B the subject, we simplify, find the values of the signs, input, then you get the answer as well. I want you to try this. Try this at home. It's not difficult. And the next one that I'm going to give you. So all what you have to do, take these values, sine B, given B, find B when given are A, that of B, and that of sine A. That's one example. Try this at home, and you can go through and check. The next one will be the law of cosine. So this is the end of the lesson. We'll stop here. You can try this one at home. Until we meet next, we'll stop here for the day. My advice for you is always to stay at home and wash your hands regularly. I thank you for your kind attention.
Therefore, remain calm and hopeful.